and welcome back. Now, last week we started having a look at this C9 and we stripped down the power supply, checked the two capacitors which can cause a lot of trouble, found that said capacitors were actually okay and certainly serviceable for the duration of actually testing the machine. Now, we discovered that there was no capstan rotation and no real rotation, but there was head rotation when putting the tape into the machine. So one of the things I'm going to do is to check out the two boards underneath. There's a number of components on here that could potentially cause the problems that we're experiencing, and I wouldn't mind checking those out before I go any further. So I'm going to get this bottom panel off and we'll be back shortly. So with the panel off, we have both the underside boards and they are mounted into the bottom of the deck, or the base of the deck. We've got the screws marked with arrows, which are the ones that we're going to need to remove. There's a lot of these sticky pads, and on the SLHF950 that I've got, the friend of mine that did a lot of the work on that actually said that these sticky pads actually corroded some of the components. Now, looking at these, I don't think that that is the issue, but I will test these components anyway, just in case. So looking at the boards, it looks like this one is to do with picture, colour, luminance, chrominance, etc. That is colour, chrominance, and servo control. So this board here is our servo control board. Now, I can see, just looking at it, there are a couple of dry joints. That looks quite dry. That looks dry. That is God knows what. These ones are actually missing solder, but that might be from the factory. It's quite possible they're not actually connected. Looking at the IC, if you look at it, they're not actually connected to anything. So we might have the usual Sony dry joints to contend with, but certainly what I want to do is to get this board out. This one I'll leave where it is, but this one I want to get out and have a look at. So let's aim down onto this board like so, and let's start taking out these screws that hold it in place. Right, I'll get underway with that and we'll be back shortly. So, a couple of items that are mentioned that you should check. This fuse, and these fusible links. So they're certainly first on my list for being checked. So we'll just grab out my multimeter. And first off, we'll check for continuity on these fusible resistors. Actually, what's quite nice about this, you remove the screws and it hinges up on those plastic plastic hinges. And this is the one that it says in the instruction service guide, if you want to support this board, you actually support it with a beta cassette. It seems to be probably the best thing to actually do with it. Non-head rotation can be caused by this little item here, which is the Hall effect sensor. Now, there's glue on it which actually becomes corrosive, becomes hygroscopic, and depending on how it's been stored, it can corrode the legs. Now, if I look at these, it doesn't actually look too bad. The glue doesn't look like it's actually corroded anything, probably because this has been stored in a dry sort of area. That's another Hall effect sensor on the Capstan. So anyway, let's check out continuity. First off, on these fuses, yep, they're fine. Well, that one's fine, rather. This one is also fine. That's fine. That's fine. So they seem to be okay. Right, let's grab some power. Power it up. So there you go, you've got head rotation when you obviously plug it in. It's when you put a tape in that things get annoying. Might not necessarily want to load when it's upside down, actually. So it laces, and then you hit play. Now here's the weird thing, if I hit play and then hit pause, Capstan almost just spins up way too fast. I'll just show you that there. So you hit play, hit pause, Capstan goes way too quickly. So let's have a look and see what could cause that. I'll just power it off so I don't overheat it. Right, let's see, let's have a look. So I've just zoomed in to where the Capstan actually comes into the deck. So it actually comes in around this section here. And funny enough, there's another fuse I forgot to check. So just quickly check continuity on that fuse. Fusible link, sorry. Actually fuse and fusible link. So the fuse is fine. This fusible resistor also appears to be fine. Right, we need to work out where real voltage is derived from. And to do that, I'm going to need to consult a circuit diagram. So, just get this back in place. Okay, right, let's have a look at circuit diagram, so bear with me. So IC602 is responsible for take up reel, supply reel, so that's pin 25 and pin 26, so there's 26 and 25. So pin 25 and pin 26. Right, so if I put something onto pin 25, and if I hit well, that seemed to give me some voltage, but I don't know if it was the correct voltage. So let's try that again. So 0, anything. So 26. You see, the thing is, I don't know if that is an error with the, or if it's just almost like residual amounts of voltage. There's like a burst and then nothing. So there's a burst of voltage and then there is nothing. Which would suggest to me that burst of voltage is it telling the reels that they need to rotate respectively. So once it's issued that command, it doesn't need to do anything else. Then it would get into the driver side, I would guess. So 25, 26, yeah. Right, let's examine that circuit diagram again. Okay, this is how it's supposed to work. So IC6, hang on a minute, IC006. IC006 is 002, it's 13, 312, 305, 1, 4, 3, 2. So this is the SS11 board. Look on the other side. 2, 1, 4, 3, 1, 2. But one of those weird ICs that stands up. Yeah, IC005, IC003. What's this one? IC 00. I think it's this one. No, that's 5. So that's 5. IC610. IC 303. 305, 312, 304. So the thing is, IC601 issues the command. That then has to go into the reels section where it gets translated into a request to actually drive the reels. And 001, 004, 3, 8, 608, 610, 5, 3. What's this one? This one here is 006, that one. So 006. Which is this one here. Now, we look at the block diagram. When you issue a, let's have a look, So when you hit playback, that's rev search. Forward search, review search, tape end, playback. So load unload, that seems to work because that does get triggered. FWD, that's forward search, that's on pin 10, and that goes out to Q00, so Q01011, which is going to be a little transistor driver of some description. So Q011, Q004, Q029, 013, 014, 015. We need initially to check to see if there's any pulse on that pin. So basically it's a switching IC according to this. So pin 10, which is, pin 10 is this one. So let's just get that earthed over here. Get earthed onto something. That's open at 1.54 volts at the moment. So if I hit play, or fast forward, so play, sees a slight drop and then it goes. Alright, if I take it out and put it into standby, 0 volts, take it out of standby, you've got 1.5 volts on it, which would make sense because that's going to be live. That's just going to be awaiting a signal, I guess. Right, so after pin 10, it goes into, comes out on pin 14. So 14 is this one here. And that has voltage against it. Only 1 volt though, which seems very low, but looking at some of the inputs, that makes sense. I mean, 1.5, 2.27, that's just going to be signaling voltage, I guess. The power for the real is actually 12 volts, and that's coming from somewhere else. So that's not actually coming from that board by the looks of it, that's going to be coming from elsewhere. And there should be some kind of output on pins 2 and 3 of CN003. So CN003, that's going to be a connector. CN003 is, I want to say this one here. Yeah, I think it's this one. So that CN, oh no, that's 306, sorry. 6, so CN002, CN604, CN617, CN, I want 003, So 002 there, CN003, this one, CN003, this one here. So yeah, there, so there should be something out of that. There's pins 1 to 6, and according to this, pin 2, 3 and 4. So pin 2 goes to the take-up reel, pin 3 goes to the supply reel. So pin 2, which is, so 1, that's pin 2. 0.49, so 0.49 volts. Let's just drop that down. And let's go to pin 2 there. So if I hit, so pin 2 is, if I just check my, pin 2 should be rewind. So that spikes up to 12 volts. I don't know if you could see that. I'll just put that there. If I do pin 2, let's do that again. Pin 3 will be fast forward, which is this one. Pin 3, that's interesting, pin 3's got nothing. So pin 3 goes through, if I follow it back, pin 3 goes through Q25 and 26. There's a driver, Q24. There's an amp, which is IC002, but that's the same as the one that's being used for rewind. Then you go through PWW, which is IC004, but again that's the same as being used for rewind. Then you've got drivers Q025 and 026. Now, forward on pin 6. And so rewind and forward. So pin 7 on IC006 is going to be for the supply reel. So pin 7, which is here, has 1.31 on it at the moment. That drops down to, that pulls it down to 0 for some reason. Does that do it on pin 6? If I do fast forward, that doesn't get pulled down to 0. So what does it mean when something's pulled down to 0 volts? It means that there is a voltage draw further down the circuit. Could be one of those drivers, maybe, I don't know. So right, let's have a look at those Q numbers again. So you've got 0025 and 016. So 0025 and Q016. Probably easiest to check it on this side. 29, 30, 4, 28, I'm just going to unplug my soldering iron for the minute. I don't think I'll be doing any more soldering at the minute, especially if it's those power transistors that are at fault. Q011, Q027, Q020. Should have to go over to this side, to be honest with you. Q027, Q023, Q010, Q030, 22, 15, 14, 11, 28, 6, 25, 26 I'm looking at, but I'm also looking at 24 as well. So if we start with 24, because it initially goes to 24, so 24, 46, 23, it's going to be in this cluster here. So this is the real section here. So it's going to be in this section. So I think that's probably the best place to start if we're going to be troubleshooting this. There's no real rotation, so before even worrying about the capstan, worry about this section. I haven't actually had a look inside this box. Just unplug that a second. Ooh, many things. God, that's aged. No, there's nothing in there. 20, 23, 22, 27, 20, 15, 14, 13. Twenty-one, 14, 15, 22, okay, 22, 23, 21, so 21, 20, if you can see that on camera, sorry, 21, 22, 23, 20, 27, 14, 15, 22, okay, 21, 22, 23. That one's 20. That one is 27. This one is apparently 12. This one is 19. This one is 11. 7, 8. Thing is, it should be in this little cluster here because that's where the other ones are. We got 31, 32, 2, 1. So they're going to be in the general vicinity of IC6. They've got to be, because they're pretty much immediately next on the diagram. What were those numbers again? 27, was it 26 and 27, or 27, 28? 25, 26. Where does 27 come into play? 27 doesn't, although we've got 24 coming in first. So 24 is 22, 23, 20, 27, 12, 19, 11, 10, 29, 30, 7, 8, 9, 20. Right, start with QO24. That's going to be near, so that's IC004 there. That will feed into, what pin is that coming off of IC04? So IC04 is feeding that from pin 1. Right, pin 1 is here. Pin 1 comes up. Pin 1 comes up. I do wonder if it's inside this bloody box, to be honest with you. Thing is, you're not really going to be able to easily see that because it's covered in this this bloody plate. And I've just turned the soldering iron off. Yes. As you want to start with 24, so pin 1 comes off. Easier to follow it this side, so pin 1 is here. And the thing is, pin 1 on this side doesn't go anywhere. Oops. Right, bear with me. think I found the problem. So, according to the circuit diagram, they do actually reside in here, and there's one of them that has gone quite crusty, actually. Like it has been subjected to a lot of heat. So that'll be what's bringing down the voltage. There's obviously a short inside that diode, or transistor rather. So that, I think, is the problem. And thankfully, that's actually quite an obvious bit of damage to it as well. I don't know if you can see that, but it has charred this plastic around here. So I'm going to try and get one of those. And I think I might need to get a second-hand board to be able to do that. Because I've got a feeling that they are going to be very expensive, and only Sony, and nobody else actually supplies them anymore. So, a semi-positive ending. If you found this interesting, don't forget to hit the like button. If you've got any suggestions, feel free to let me know. And yeah, I'd like to thank you all for watching as always. Thank you very much. Speak to you soon.